Wait, we are skipping forward. We are on dictionary-based analysis. So we've taken you through all of the typical steps for preparing a text set, a group of text for an analysis. We've worked through cleaning text, preparing text, creating a text object like a corpus or tidy text, and creating a document term matrix. And now we can finally start to look for patterns in text. And the most straightforward way to do this is through a dictionary-based approach. And a dictionary-based approach is one of the more, the earlier versions, things like earlier I mentioned Laswell counting utterances, right? And this is a case of word counting, right? And so here, we're simply making the assumption that we, the researchers, know what words mean. And if we find, we can develop a list of words that we think are associated with some theme or topic we care about. Could be things like whether or not a group of texts have negative sentiment in them, right? We might come up with a list of words that we think convey or negative sentiment. And so basically, we're then just going to write code that goes through our text, counts the appearances of those words, and make visualizations. So let's check it out with our Trump tweet data frame. Once again, we're loading that from my GitHub site here. We're going to use tidy text and dplyr. And we are creating tidy text from those Trump tweets. We're also going to drop stop words like we did in a previous step. We are also going to drop, using a grep command, https, t.co, AMP, and RT, and these are all artifacts of the links and the proprietary link structure that Twitter uses. And again, if you're new to dplyr, if you're new to piping, a lot of stuff up here is going on that's going to seem a little strange. But essentially, remember, each line, when we see a pipe, is passing whatever was produced on this line to the next line. And both objects and functions and instructions are being passed, and that makes it especially difficult to follow. But essentially, first we're taking out stop words, then we're taking out these additional terms that we don't think are going to convey much meaning in our analysis. And then we're producing a new data frame that just simply includes the top 20 words that appear in this corpus of Trump tweets that was collected about a month ago in 2018. And so one thing we very well may want to do is plot these, look at some basic descriptives around which terms are appearing more than others. Here's some ggplot. We're taking the object we just produced in the previous step called top 20, which is top 20 Trump terms that appear in the most tweets. We're just making a bar graph. And we've got some aesthetic elements here specifying how we want the background of the plot to look, what the title is, whether we want a legend, and so on and so forth. And if you're new to ggplot, there's great documentation online. It's one of the real strengths of our, again, part of the tidyverse. And here's what we might find from a very simple text analysis, right? What are some of the most common words? American, you can't read this, but if you're zooming in, border, country, day, Democrats, fake, honor, house, jobs, media, military, news, people, and so on, right? That sounds pretty familiar. That sounds like we're finally on to some signal after. Think of all the steps we had to take to get here, though, working through all the pre-processing and coding and data restructuring steps. All right? One thing we often want to do at this stage is not only identify common words, but create metrics that allow us to reward or weight the appearance of unusual words. And one way we very often do that is to calculate a metric called the term frequency inverse document frequency. And this is very often abbreviated as TF-IDF. And all we're doing here is taking a corpus, and we've got a given term, and we want to calculate this metric IDF, inverse document frequency. and we've got a number of documents, and then we've got the document frequency of that term, and we're just taking the log of that. And so if we have high inverse document frequency, we've got a weird word, and low inverse document frequency, we've got a common word. Why might we want to do this? Well, let's look back at our terms here, right? We have terms like America, and let's say we weren't just wanting to analyze Trump tweets, but let's say we're looking at all elected officials, right? Probably most of our elected officials are going to mention America a lot, right? Or maybe they'll mention Twitter a lot, or something like that, right? And it really doesn't convey much meaning to us in an analysis, and so we maybe want to penalize it. We might maybe want to make it less. We want it to carry less influence when we do our classification. And so I'm briefly just showing you this because we're going to use it in subsequent techniques like topic modeling and like text networks. Okay. So if we want to calculate the term frequency inverse document frequency in tidy text, we can use code like this. Once again, we're starting from the Trump tweets object, so that we've done a few of these steps in previous slides. This unnest tokens function is transforming that data frame that we pulled from Twitter into tidy text, where each line is a word. Here we're removing stop words. Here we're counting words by their frequency, which we need to do to calculate the term frequency inverse document frequency. And then here we've got a function called bind_tf_idf that is going to create for each word the term frequency inverse document frequency. And we can use that to kind of try to figure out what's the most powerful, weird word. That's one way of thinking about this, right? And lo and behold, what's the most powerful weird word? Stand for our anthem, right? And that actually is kind of, that is a very telling word. This refers to for those of you who don't know, the debate about American football players kneeling during the national anthem, where it's customary for people to stand. And of course, this provoked a virulent political debate about the rights of athletes to engage in political protest. But it was something that was very characteristic of the Trump narrative and platform at the time. Okay, so term frequency inverse document frequencies and regular word frequencies are, can be pretty meaningful after we've removed stop words and pre-processed our text. But very often we don't just want to count words by their frequency. Again, we have some kind of knowledge about a theory, and we want to then develop our own list of words to track in a corpus. And there are a variety of kind of off-the-shelf methods, R packages, standalone software that will perform dictionary-based analyses for you based on other people's dictionaries or lexicons. These are groups of words that people think are associated with some type of theme. But you may also want to create your own. And so let's do a quick little toy example here. Let's say we wanted to count the frequency of terms about the economy and in these Trump tweets that we've been looking at. And here we have a list of completely arbitrary economic terms that I came up with: economy, unemployment, trade, tariffs. And all we're doing here is we're creating a character vector, or vector of characters. And we're then going to use another package popular for string management or string manipulation called stringer in R. Earlier I mentioned that R used to kind of lag behind Python and kind of basic text preprocessing. So if you're coming to R from Python, there's a lot of new packages such as stringer, such as tidy text, such as QDAP, which have a variety of really useful functions for core kind of text cleaning techniques. We're going to use stringer, a function called string detect, to subset our Trump tweets. And here we're moving back into base R convention instead of dplyr in order to produce a new list of documents within our corpus that have mentioned these economic terms. And so first we create that object, and then we browse that object. The variable in that object that contains the tweets is called text. We're looking at the first two of them. And we can see here that both of these texts, right, are about the economy to some extent, right? Here's our term economy, which got picked up. And here's trade down here, right? So, not bad. We could do some meaningful analysis with this simple strategy. We would want to get much more sophisticated and systematic about how we identified terms about the economy. We'd want to have a much longer list. But assuming that we could make the assumption, and this is an important point, that each word has one and only one meaning, then we can do a lot with a dictionary-based approach. A key problem, as you may already kind of anticipate, is very often single words not only have multiple meanings, but assume those different meanings based upon their co-occurrence with other words. And so what we'll see as we get into things like topic modeling is we're going to drop the assumption that each term, bless you, has only one meaning, and instead we're going to allow terms to carry, to assume different meaning when they co-appear with other terms. But for now, most people who get into the field of quantitative text analysis at one point or another need to do some kind of dictionary-based approach, and this is a very simple example. Another very popular form of dictionary-based text analysis today is sentiment analysis. So many of you have probably heard of this type of thing, right? We can track the valence of a text. So very often we don't care just about whether or not a text is about a theme, but whether that theme is being discussed negatively or positively, and so on and so forth. And so in sentiment analysis, we typically come up with a lexicon, a list of words that we think carry positive meaning and negative meaning. We then, in some way, assign a numerical score. Maybe negative scores are going to be negative words and positive scores are going to be positive scores. Or maybe we count the number of words. But in some way, we're counting word frequency in order to extract the sentiment of a text. And there's a lot of different sentiment analysis tools, most of which are not very great. Why? Again, because we assume that each word has one and only one meaning. So that I'd hate to be the president, I hate the president, right? Vastly different meanings. Both are using the term hate. In 99.9% of sentiment classifiers, that hate is going to be counted as a negative word, and hate president is going to come out, right? So as you can see, that's not always a great assumption, but it's not a completely unmeaningful assumption either, especially if at scale. Usually when people use the term hate, it conveys negative value. And so here we're looking at, from the tidy text package, we are looking at words as they've been scored by the AFIN sentiment analysis tool. Tidytext has a number of sentiment classifiers built in. There are dozens and dozens. In a few minutes, I'll show you some comparison of them and how they score things differently and how they vary. And we'll talk a little bit about how to choose the right one. But before we do that, let's try to classify some of our Trump tweets according to their sentiment. And this time, we're going to use a slightly different sentiment dictionary. This one is created by Bing Liu, who's a information scientist. Importantly, this classifier was trained on Yelp data and other review data. And many of the most popular sentiment classifiers are trained on those data sets. And so when we apply this data set to something other than reviews, we're making the assumption that when people talk about, say, an Amazon product, they use the same type of language when they're talking about politics or something like that. Is that a reasonable assumption? Maybe yes, maybe no, right? But in many cases, we would love to have a corpus-specific sentiment analysis tool. And certainly as we move into other languages besides English, then one needs to, of course, have different sentiment dictionaries. So here we see our sentiment classifier applied to the Trump corpus, and the Bing classifier will assign either a positive or a negative score, a binary kind of decision. And it will then aggregate those using this code here, this count here, which is part of dplyr, of course. And so what we're seeing here is we've counted the sentiment of tweets by day, or sorry, by time here, and looked at how many positive or negative words were in each tweet. And now you may remember yesterday, or if you were watching yesterday, the lecture on collecting digital trace data, I mentioned that date data is a bit of a pain, right? Because of time zones and because people represent dates in different ways, right? Some people might abbreviate the month, other people might use numbers for a month. And because we all talk about times in different ways, not only because of time zones, but also because of just how we describe time, whether or not we include the year or not when we do a timestamp, we need to find a way of putting all our date objects, or our date representations of dates, into the same format. This code here is an example of how to do that. This es.date function reads in a character string, and here I'm specifying where the year is, where the month is, where the day is, and that there's dashes in between them. And then this X here describes a universal kind of timestamp that's very commonly featured in especially social media data, but a lot of data sets, a lot of time formats, that is. And we could have also created Unix time or something like that, which again is the number of seconds that have elapsed since January 1st, 1970. We want to probably keep the date, though, if we want to do things like visualize it, right? So let's say, for example, we want to count the number of Trump tweets with negative sentiment by day. And so here again, we've taken our tidy Trump tweets. We've run the Bing classifier on them. We've dropped all positive tweets. And then we've counted the number of negative tweets by day. And then once again, we use some ggplotting. Here we would produce the following graph that shows the frequency of tweets with negative sentiment over time. So here we're looking at April 2017 all the way up to April 2018. And on the y-axis, again, is frequency of negative words in Trump's tweets. And whether we see a trend there or not depends on, probably a lot of things. Maybe there's a slight upward trend, let's say. By the way, if you applied a different sentiment classifier to the same tweets, you might be interested to see how much they can vary. And that's because, sentiment dictionaries are often trained or calibrated using different data sets. So one trained on Yelp might produce something very different than one trained on all words in the English dictionary, when we'll look at one of those in just a second. Keep that in mind. Now let's say we wanted to get cute about this and do some kind of analysis to compare sentiment with approval rating. And this is just to kind of try to mash up some of the skills we've been learning yesterday with today. Let's read in some data from the polling site 538 here. And let's say this is the overall approval rating of Trump by day. We're doing a lot of work to clean up the data and plot it, restructure it, ggplot it here. And then we need to standardize our date format. But if we're being very uncareful social scientists, we might infer when we look at if we notice that this is April here, if we are seeing an increase in negative sentiment, that begins somewhere around here with, correlation is not causation, huge caveat here. But, and this is, by the way, that's the type of uncareful analysis that has led many people outside our field to caricaturize our field. And so, this is an example of where we would want to know much more about what's going on in the world. And even then, we probably wouldn't be content to say that the sentiment of presidential speech determines approval ratings, right? I put this in here partly because we're going to use these data in our group exercise today to try to maybe come up with a somewhat more sophisticated answer to that question. Okay, so there's many different dictionary-based approaches. And one that's become very popular in our field, it was used in, for example, the emotional contagion experiment, and many other studies, is called linguistic inquiry word count. And the idea here was to say, rather than finding a single set of meanings, say around sentiment, and then looking in particular corpuses and coming up with a list of words, let's look at all of the words, and let's classify each word. And this was done in a fairly systematic process. James Pennebaker is a social psychologist at Texas, has been at this for about 30 years. And he not only had large groups of coders go over the entire English dictionary, so this is an English-only approach or technique, but in a variety of different corpuses like newspaper articles. Now they're looking at Twitter and so on. But it also has some external validity insofar as they validated their coding of words by through some pseudo-experimental studies. So, for example, they might prime people in a laboratory to write about something that makes them sad, and then count the frequency of words in that, and then use that to weight their classifiers and give a certain weight for the word sad in the category for certain words like melancholy in the category sad or sadness. And so the neat thing about it is it measures quite a few things. It measures things not so interesting, things maybe like verb tense and that kind of stuff. But also here we have cognitive processes, negative emotion, causal language, tentative language, certainty, inclusive versus exclusive language. These are some things a social scientist could care about, especially if you're interested in social psychology, right? There is some systematic work that's been done here to try to validate this dictionary. And it's one of the more well-validated and well-understood dictionary-based approaches. And it's been used across many, many studies in many, many different fields. But once again, it's making the assumption that a word has a single weight towards a single theme. And very often, we can't make that assumption. Or very often, we want to look at a theme that's not listed here, right? Let's say we care about politics, and we want to identify tweets about politics, and there's no theme for politics here, right? So then we're out of luck, right? We're kind of beholden to whatever this team of researchers thought was an important category to measure. Right? There is a trade-off, though, right? On the one hand, when we move into unsupervised text analysis, we're actually going to ask algorithms to do this classification for us, right? And algorithms, aren't smart. They are just going to find patterns, right? And it is meaningful that people understand meaning, right? And so one can make an argument that dictionary-based approaches in some settings for certain types of research projects are a much more reasonable approach than, say, topic modeling, because we know something about what we're out to measure, But as I mentioned earlier, there's many different sentiment analysis techniques. They've very often been trained on very different corpuses in very different ways. And that means that they perform with more or less accuracy on different types of texts. So here, for example, we have data sets from Twitter, MySpace, the BBC, YouTube, and so on. And then we have a ground truth measurement of positive minus negative sentiment in each corpus. And that's that dashed red line here. That's like what these scores should actually be measuring according to this study, which I think I have linked in the markdown. And what you're seeing here is a lot of different sentiment classifiers. Here's linguistic inquiry word count, this blue one here. And then this green one here, which is doing really well, is called PANAS-T. And some of them, you'll also note that some of them are doing better for different types of corpuses, right? Why? Because, well, let's say a classifier that's trained on Yelp data might be picking up YouTube discourse much better because there's like more internet speak, right? Or abbreviations, LOL or something like that, which may not be captured in some of these other techniques. So long story short, with dictionary-based analysis, there are certainly cases where it can be a very, very suitable method, especially when the classifier can be well tied to a theory or to, for example, a psychological process. And there, something like linguistic inquiry word count, to the extent it's been validated in a variety of settings, even in some more experimental field settings, if you're interested in reading about that, then it's not an unreasonable choice. Okay.